we introduce generative category-level object pose estimation via diffusion models. In this work, we aim at 6D category-level object pose estimation. The 6D poses involves 3D rotation and 3D translation. Given a single noisy depth image, our goal is to estimate the 6 degrees of freedom poses of objects within the same category without C/D models. Here we show comparison between our method and the state-of-the-art method, RBP pose. Note that axes with mixed colors indicate better predictions, and axes with pure red indicate worse predictions. As we can see from the videos, our method provides more accurate predictions than RBP pose. We conduct real-world object manipulation experiments to validate the effectiveness of our method. We integrate the UFA CTE ORY XARM6 manipulator with our pose estimation module to perform object manipulation tasks. The manipulator can successfully pour the milk into the target container. In this work, we aim to tackle the multi-hypothesis issue that has existed in the literature for a long time. This issue is generally caused by the partially observed point clouds or symmetric objects. Previous methods failed to solve this issue fundamentally. End-to-end regression methods could only be supervised with a single pose due to the regression-based training, while matching-based methods made ad hoc designs and lacked generality. To address this issue, we propose a generative approach that estimates the data distribution of the ground truth examples. Specifically, we train a score network to generate poses via a denoising process. However, the generated pose might be an outlier. Hence, we further train an energy network for filtering out the outliers according to the output energies. During inference, given an unseen point cloud, we first sample a group of pose candidates via the score model. Then, we estimate the likelihoods for the candidates via the energy model. Finally, we rank the candidates with the energies and then filtering out low-ranking candidates. The remaining candidates are aggregated into the final output by mean pooling. Our method achieves the state-of-the-art performance, REAL 275 dataset, and outperforms previous methods significantly. In the rigorous evaluation, metrics 5 degrees 2 centimeters and 5 degrees 5 centimeters, our method surpassed 50% and 60% respectively for the first time. Besides, compared with the method GPV pose with the same input data, our method exceeds it by nearly 20% in both rigorous metrics. Even compared with state-of-the-art methods DPDNA, which utilizes RGBD and shape prior as inputs, our method still shows great advantages. We take lead in 5 degrees 2 centimeters and 5 degrees 5 centimeters with 6% and 10% increments respectively. Furthermore, we present the results of the candidate that is closest to the ground truth. The amazing performance indicates the great potential of generative pose estimation methods. Our method shows a better generalizable ability than previous approaches since we don't need shape deformation process. Without any fine-tuning, our method could generalize to novel object categories sharing similar symmetric properties. Take the can as an example. Our method even surpasses all the baselines directly trained on can category greatly. With minor adjustments, our method can be applied to pose tracking tasks. Our method could achieve comparable performance with previous methods without specific designs. We successfully integrated our 6D category level pose estimation framework with various robotic manipulation tasks such as pouring, stacking, and handover. The exceptional performance of our method showcases its tremendous potential in real-world applications involving robotics. In conclude, we propose a generative approach to solve the fundamental problem, multi-hypothesis issue in category-level pose estimation. We leverage the energy-based diffusion model to aggregate pose candidates generated by score-based diffusion model. Our framework achieves exceptionally state-of-the-art performance on existing benchmarks, symmetric objects, pose tracking, and generalizable ability.